Hello, good morning, everyone, and welcome to this first webinar of what we have called the Head Start Week. I'm Álvaro Arrue from A Plus IDIADA. I'm the project coordinator of Head Start, and I would like to spend a few minutes before we start with the core of the meeting today to explain a little bit more what is Head Start, so I can give you a background where all this is coming from, and what are we planning to have for the next days within the webinar, during the Head Start Week and the different webinars. So let me start. I don't want to steal more time from our speakers. And well, let me show you. Head Start project, harmonized European solution for testing automated road transport. I've already presented myself. So what is Head Start? Okay, Head Start, it's a Horizon 2020 a European Union funded project, and the one that was granted in the former ARTO1 call back in 2018. It's a research and innovation action, and we started the 1st of January of 2019, so we are pretty close to the middle of our project. Okay, it's a budget. We have around 6 million euro funding from the European Commission, and we are 17 partners. We'll explain you a bit more about the partners. Just a quick overview. This is our website. This is our social media. Please stay tuned to all the different news, events, webinars, and downloads that will be available through our webpage. Who we are in Head Start. As we said, 17 partners from different member states in Europe. As you can see, we have a wide spread of the different kind of partners, from the Netherlands to Greece, from Spain to Sweden. What we just wanted to highlight, as we see here, what we try to put together in this project, it's members from the different initiatives that are taking place at European, but also at member state level in the context of connected and automated driving validation. Okay, so for example, TNO is the coordinator of Ensemble project on track tuning. ICCS is the coordinator of ICT for CART, which is another ART project. We've got Ertico, which is coordinating also Arcade, which is the support action also from the ART program. But for example, we also have IKA, which was highly involved and is highly involved in what we call the Pegasus family projects, which are German national projects also on safety validation, or BETECOM, who were the coordinators of MOVE and are very much engaged in French national projects. I'm from SAFER, for example, SAFER Joint Research Unit, which is an umbrella in which you have Chalmers, Rice, Volvo, Veoneer, different actors. Also, would like to say that we have this homogeneous mixture of partners here. So we've got, for example, type approval technical services like RTW or A Plus IDIADA. We've got also Euro NCAP accredited laboratories, in which we can include PAST, TNO, IDIADA again. So we wanted to have this good representation from the industry, from the academia, and from the organizations for the correct implementation of the project. Let me move on and explain you what is Head Start about. Okay, so just a concept overall of what we are doing. At the end of the day, we want to create this methodology I will explain later, in which we will review all the different stages. We will understand and we will work on how to include what we call key enabling technologies in the whole process. But we will test it with different environments and we will demonstrate. But just wanted to highlight that we are going to make this process that answers to the project objectives. So Head Start, what is our aim? What is our vision? To define testing and validation procedures for connected automated driving functions, okay? Including, and this is very important, its key enabling technologies. And for this project, we consider that key enabling technologies for connected and automated driving to be communications, cybersecurity, and positioning, okay? How? By cross-linking all the test instances. What is a test instance? Simulation, proving ground, and real-world test. It's not just one of them. We need to have a good approach to take the best of each one of them in a coordinated way. Finally, to validate safety and security performance according to what we have defined as the key user groups of the project results. And we understand that these key user groups will be: one, technology developers, and here you may find industry, so OEMs, tier ones, tier twos, academia. What we call consumer testing, that of course, as we are in Europe, it will answer more to what we better know as Euro NCAP, and to type approval. And I would like also to highlight here that when we are referring to type approval, it's not that we're going to make a regulation. It's not our job as a research and development project to develop a regulation, but to provide the necessary insight or technology technology information, so we are this can be taken by the appropriate organization to create new regulations. It's an important point. Something similar happens to Euro NCAP. We are not in charge of making the protocols, but we can provide information to make them. And how are we going to do this? Well, through different 5 stages, 5 in particular. First of one, identification. What we did at the beginning of the project is to understand what is going on out there, what are the different elements, projects, initiative, activities that are focusing on validation of connected automated driving. And this all fed the rest of the project, but in particular our second stage, harmonization. The idea here is all this information that's going on, we did efforts to understand in which areas it's possible to harmonize or if there are potential gaps. It's very important, and it's an internal motto of the project to provide this harmonization in order to avoid potential fragmentation. We have different initiatives, different projects that are dealing with validation, but there is let's say usually validation on a project initiative, it's tailored to that project. And we want to do here is to have this generic harmonized approach for this. We are now entering our third stage of the project, which is more on development. We are currently starting the process of go to the lab, develop all the necessary tools, procedures, in order to be able to get to our fourth stage demonstration. So we will have 3 different use cases, 2 of which of them will be discussed during this week in the following days, that will act as demonstrator of the previous work on the validation of our validation methodology, if you let me explain it that way. We have a final 5th block, which is rich consensus, and how to do this. This one is transversal to the whole project, and it's from the beginning to the end of the project. And this will be done, and is being done in what we call our expert network. And to do this, we want to have all the experts from the different stakeholders in the community. So 1, we can show them what we are doing, the results of our research, and 2, ask them for our opinion. And today is a good example of what we are doing in this field. We have organized this expert group in 6 different subgroups. 3 of them are answering to the needs of the key enabling technologies, so cybersecurity, communications, and positioning. And the rest of 3 ones are important for the development of the project itself. So we have one on scenario selection, another one dedicated to consumer testing, NCAP programs, and finally a 6th group on type approval and legislation. Okay. We also have another activity in which, if you are in an initiative, an activity, a project, and you want to cooperate with us, we are open to do that. So you want to have more information on methodology, follow the Head Start methodology in your validation activities in the project, please come back to us and we can help you. Small status updates. This is what you can find in the Head Start project webpage, which I recommend you to visit. These are the 6 deliverables with technical content that have been finished. The first 4 ones can already be uploaded, and the second 2 ones are the ones that we will discuss today in this webinar and will be soon ready to be there. Let me summarize a bit what is coming during this week. So we have 1 webinar on Monday, Tuesday, Thursday, and Friday, being this the first one of our series. We will see today how we want to interact with you, an open discussion, so you will have the opportunity to discuss about different topics, the methodology, the selected use cases, how we will apply this methodology that will be explained today to the different use cases, how to validate an ID driving function, how the CATs should be handled, and we have a final webinar on Friday, which is dedicated to cybersecurity in the context of CAG validation. So today we are here, we are now here, we have a presentation of the overall methodology. Tomorrow, I really encourage you to also participate, in which we have a dedicated one for trackpad tuning, in which what we will explain today will be explained tomorrow also, but in the context of this particular use case of the Head Start project. Same situation for Thursday, in which we will use traffic jam, which is one of the chosen use cases in the project, and how we can apply the methodology to this particular use case, how the key enabling technologies like positioning should be tackled. And finally, on Friday, we have a different approach. In this case, we will take cybersecurity as a motto, as a lead, and we'll see how we can, how we should, or how do you think we should tackle it in the different use cases. Okay, so webinars are free and independent. Thank you for being in this first one. I really encourage you to join the rest of them. And of course, they are independent. So if tomorrow you cannot make it, the one on Thursday you can make it. Don't worry, you can do it. No, this is something that doesn't need to be the whole week to be understandable, and we still need your feedback. So please register to find out more information about this webinar, and this can be done through our webpage, Head Start Project, and in particular Head Start Week. And of course, more information, and that's from my side. Before moving on to our first presenter of the day, just wanted to highlight some items for the organization of how this webinar will be. First of all, will be repeated in a few minutes, but I will highlight it a bit more. Please write your questions in the box that you have on your screen, and it will be used for the later discussion. The webinar will be recorded, also for your knowledge, and very important, the slides will be shared. Okay, so you don't need to capture things or write down things. The slides will be shared. And said this, please let me move on to the next, to the real activity of today, which is the overall methodology. And this webinar, it will be chaired by Nicolas Wagener from IKA. Nicolas, apart from being the Work Package 2 leader of the Head Start project, which is has the responsibility of defining the overall methodology, he is also a very active member of different initiatives in Europe. He was in Pegasus. He's currently involved also in the verification and validation German national project, and he is a well-known active person in the validation community. So thank you very much. Thank you for being here. Please do not forget, if you are interested, to join our next webinars. And Nicolas, the floor is yours.
Thank you, Alvaro, for the introduction. And welcome to the webinar on the methodology and the process. Yeah, to start with it, I just want to shortly introduce all the three speakers today. So it's Alvaro Aru. You already heard him right now. Then it's myself and Bernhard Hildebrand from Virtual Vehicle, who will present the process later in the webinar. So for today, we will have the short introduction you just heard into the Head Start project, then some information on the Head Start Week, which Alvaro already introduced. Then we have the Head Start's overall methodology, which we presented right now. And then we have the Head Start's process, which is a more detailed view into the overall methodology as an application. We have a short question or a question and discussion slot after the overall methodology and after the Head Start's process. So after each presentation, we have a question and answer slot for you. Then there are some webinar rules. The webinar is being recorded and which will be available, as well as the slides on the Head Start website after the meeting. Then the discussion, the questions will be discussed after each presentation, as I said it before. So please remember the slide number if you have a specific question on one of the slides. so that we can jump back to the specific slide. Yeah, what is the goal of this meeting? It is not just to present to you the Head Start methodology, but we are highly dependent on feedback from experts. So we want to get expert feedback on the Head Start methodology to refine the process, to implement it into upcoming deliverables, and yeah, to use it for the methodology and the process. Yeah, so let's get to the overall methodology. Special thanks here to Patrick Weissensteiner from Virtual Vehicle and Jean-Baptiste Coget from Vedacom. Yeah, the agenda for today is then the overall methodology. First, a big picture, then we take a more detailed look into the scenario selection and relevance metric, then to the process of the allocation and scenarios, and finally into the testing. So where does the Head Start methodology come from? The Head Start methodology is based on a state-of-the-art analysis of international and national projects from all over the world, especially Europe, looking into Germany, Pegasus and VMD methods, then looking into France, the MOVE project, the Ensemble project, which is a European Union project, but also into international projects like Sakura from Japan, or projects from the United States. It is a harmonization of present and past projects, and yeah, it turns out that it is a scenario-based, data-driven approach to test only relevant selected scenarios, utilizing a common database to analyze the data. So this is the general process of yeah, this harmonized process. So we're starting at the left with the input data. It can be from different sources. It can be a field operational test. It can be a test drive. It can be accident data, but it can also come from drones or any other data source. So it's not limited to any specific data source. And in the next step, the data is abstracted and integrated into the database so that we can get a good representation of the reality in a database. And we use this representation to generate output with a test concept and test it on proving grounds, X in the loop, and in the simulation. Finally, the results are evaluated, and of course, there's a feedback loop here, and there's more input, like the generation of complete scenario space, which is important. But this can be seen in more detail on the next slides. So this basically is the Head Start methodology, which I will show on the next slides, which is the process I showed before in a more detailed way. So we once again have these different inputs here, but it's not limited to these. It shall just show that there are a lot of different inputs. Then in the next step, we have the database and mechanics, and we have the input data. We have some sort of pre-processing. Then we have a scenario extraction to abstract it to an abstract level. And then we have a post-processing and the extraction of parameters to save it into the scenario database. Of course, there are several databases currently available, like the Pegasus database, TNO Streetwise, or the MOVE database, or some others. So this process may differ, but these are just the basic points which are important to have in such a scenario database. And we are not building up a scenario database ourselves in Head Start, so we just want to use existing databases because they're large projects trying to tackle this problem and trying to building up such databases. So we just defined the basic points within this process and the scenario database itself. And then we have some other input, which is quite important. We have the injected scenarios, which can be based on expert knowledge or on completeness, so which can be constructed scenarios and can be an input to the scenario database. So then in the next step, we have the selection of relevant scenarios and the stochastic variation, which can query for scenarios, and the output will be an exposure, the logical scenario, and the parameter distribution. It is important to mention that within this process, it is functionless, so there's no specific driving function here in this process. It is just a representation of the reality and shall hold all scenarios or relevant scenarios within this database. And just after, and then just in this step, in the selection of relevant scenarios, the driving function with its ODD and the CATs and so on will be included in the process. So the query, of course, will take into account the ODD, but within the scenario database, the ODD is not specifically regarded, so it can be used for several driving functions. And then, of course, we need to take the use case into account, functional requirements, abstract scenario description, and so on within this selection of relevant scenarios. And then in the next step, we have a stochastic variation because we have here a parameter distribution, and we want to test the whole parameter space. Therefore, we utilize the stochastic variation to test the whole parameter space. And we have a more detailed look later in the slides on the selection of relevant scenarios in the stochastic variation. And as an output, we have a concrete scenario here. And then we enrich the concrete scenario by the 3 different key enabling technologies we focus on in Head Start. Then in the next step, we need to allocate our scenario on the different testing capabilities. And we have the virtual simulation, of course, which is quite important if we want to test a lot of scenarios with less effort. And then, of course, if we want to go more into detail, we need the proving ground testing. And in between, we have this X in the loop based testing, which can be from vehicle in the loop over hardware in the loop to model in the loop testing. Of course, we need a feedback loop here, which can be which are requirements or capabilities to show what is possible to be tested on in the proving ground or in the virtual simulation or X in the loop testing. And then we have this field testing here, which is a little bit separated from the allocation of scenarios, because we cannot really stage scenarios in the field, especially if we're looking into the dynamic moving object layer. It's quite hard to stage tests in the field. But if we look into key enabling technologies, especially into the communication and positioning, there might be important aspects like multipath propagation or blocking of signals, which can only be found with real structures, with real buildings, which can only be found in the field. So for this scenario creation on CAD layers, we can test some sort of key enabling technologies within the field by taking a look into existing infrastructure, use it to create scenarios on this layer and test it on the field. So this is why it's separated here. And then in the end, we have the evaluation, of course, of the tests, taking into account pass-fail criteria for that specific driving function. When a test is passed and when a test is failed, it needs to be decided using criteria. It's not only crash or no crash. There might be more requirements which are necessary for the evaluation. And of course, we need to take into account the human capabilities. So if and the physical capabilities. So if a scenario is not possible to be solved, neither by human nor by the driving function or by anyone else, that's not really a bad result for driving function. Yeah, and we also need to take into account the human capabilities so that we can measure how good our driving function is in regard to the human. So, and then we have this feedback loop from the evaluation into the database mechanics. Of course, we can use the results and the tests to refine our scenarios within the database, but also more importantly, we have this feedback loop to the scenario selection of relevant scenarios. So if we see that some part of this, some scenarios are very close in terms of pass and fail, then we can take a more deeper look into these scenario parameter spaces and use of stochastic variation adapted here and get more scenarios in this part. Okay, so this is the overall methodology, and now I would like to show you a little bit more of the selection of relevant scenarios and the stochastic variation. So this is basically a little bit more detailed view into this picture before. We have the scenario database, we have this query taking the driving function into account, and then we have the output of relevant scenarios here with the feedback from the evaluation. And we have the relevant scenarios, and then which are basically the logical scenarios with the respective parameter space. And then we can access the relevance for the parameters of the distribution, and we can have a stochastic variation within this parameter space, test the edge cases, try to find the edge cases, and then we combine it to concrete scenarios, which will be the output of the scenario selection as it was already shown in the picture before. So if we take a look once again here, it's a concrete scenario, which is the output. The logical scenarios and the parameter distribution are the input to this parameter space. And then in the next step, we can take a look into the allocation of scenarios, which is right here, and which will allocate to either the simulation, the Excel-based testing, or the proving ground testing. And if we take a look here, each test instance has its advantages and restrictions. Of course, the virtual testing is quite efficient, and we can test a lot of scenarios within the virtual testing, but it is restricted, especially in terms of realism of driving dynamics. It always depends on models, on sensor models, but also on vehicle dynamic models. And the proving ground testing is better in these terms, but it is, for example, it is hard to test with a lot of infrastructure, with a lot of vehicles, and to test a lot of scenarios in general. So, and then we have in between the Excel-based testing, which is a combination of both. So the objective is define how to allocate the selected concrete scenarios to each test method to find the best fit. And therefore, this is basically the picture which was just shown before. So there's these capabilities which the allocation needs to know for each testing method, and then it will be allocated to one of the test methods. And for the scenario allocation, especially for the X in the loop based testing, we can select for each component if it needs to be real or if it can be virtual, and then within the virtual simulation we can have high fidelity models, especially for if we take a look into sensors, we can have ray tracing and very accurate physical models for the virtual testing, but we can also have models with lower fidelity to test more efficiently. If we want to test a lot of scenarios, we can test them with low model fidelity and take some scenarios to a higher model fidelity, and then just sum to real sensors. But also for the environment, we can have different types of models. We can have the real world, and then combine it. And same, of course, for the vehicle dynamic model. And so we can either select everything with real, which will be then a proving ground test, or we can have just maybe a real sensor or a real ego vehicle, and have the environment as well as the sensor input based on a virtual simulation. And therefore, we try to match the minimum requirements and for the specific test, and try to allocate it as far to the virtual part as possible to keep it efficient, but still meet the requirements to have the specific realism included in the test process. Okay. So then for the testing itself, as I said before, we mostly took a look into virtual simulation testing, sil-based testing, and proving ground testing, leaving field testing a little bit separated because it's more, it's quite hard to test scenarios within the field. And since the headset methodology is a scenario-based approach, this is left to the CAD layer. So what was important to us? We have the different testing facilities, especially the first three, but also field operational tests. And then it is important for us to use unified interfaces. We use the open simulation interface, which was identified by the state-of-the-art analysis and functional mockup interfaces to include driving functions into the simulation. But also we identified open standards, open scenario, open drive, and open CRG. Open scenario is currently in version 1.0. It's maintained by the ASAM consortium, and it is an open standard and widely used in the automotive industry. So we want to use that too to have a more generic approach and to be able to harmonize the different approaches which are currently there. Open drive is also an open standard. So open scenario is basically for the scenario for the dynamic parts, to say it in an easy way, and open drive is for the static parts like the infrastructure, like the road, lane markings, traffic signs, and so on. And open CRG is a third part in these open standards. Open CRG is for the road surface, to define it in a more detailed way. And then finally, we took a look into a more detailed look into the sil-based testing. Of course, we would like to support your open scenario and open drive too. And we can use this sil-based testing, of course, also for pure virtual testing, but also for pure proving ground testing. So we can then select the different components like the driver, but also the pedestrian, traffic, environment, vehicle, the HMI, or any other aspect or component of the vehicle, and can select the realism which is necessary. So we can go from fully abstract or virtual to very real, and therefore select the optimal test setup for our test. But then, if we combine different simulations, or a simulation with a proving ground, or a simulation with a hill, or any other setup, we need to have a separate scenario control, which is basically the manager of the test. So if we would implement the open scenario into each testing facility, then the test might not be valid because they have different instructions. So we need a separate scenario control managing the test and the test execution. And then we have the initial setup, of course, which needs to be available in all the different environments. In the end, we can assemble the results. So we have a co-simulation here between these parts or components, simulations, and then we have assembled results, which go then finally to the evaluation. So to summarize the methodology, the ETSAT methodology is a living process. We need some expert input to refine the methodology. We had a state-of-the-art analysis in the beginning of Head Start, which was already presented in another webinar by my colleague Jean-Baptiste. We used this state-of-the-art analysis to define the Head Start methodology. But since it is a very up-to-date topic, and there's a lot of projects going on, we always need more input from experts to keep the Head Start methodology up to date. We would like to keep it generative and modular so that it can be used with different databases, for example, with different test methods and capabilities, but we would like to define a common and harmonized approach within Head Start. And then the more detailed process of the methodology will be introduced in the next presentation by Bernhard Hilbrand. So this was just the methodology in general. Okay, so I would say that we have now a short question and answer round, and then we go to the next presentation of the process, and after that we have another question and answer round.
Hi Nicolas, so far we have one question from Thomas Weck, or a comment that says that the main path for allocation should be simulation, and only when simulation cannot deliver the required quality, other environments should be chosen.
Yeah, that's some good input. We think in the same way that we try to allocate everything as virtual as possible, if you can say that. So allocate everything mostly to the simulation, and if we need some components to be real, then we can go to X-in-the-loop testing, so that we just have these components in a real environment, for example, the hill or vehicle-in-the-loop approach. And just if we need to test everything on the proving ground, this is our last allocation method. And so I think we agree with that.
And then we have another point of view from Eric Water, hope I pronounce it well, that simulation never capture unknown unknowns. Which is another argument that maybe there's other than simulation that we should use.
It's a little bit hard for me to answer that, because I'm not sure if I get the question right. But yeah, you're right. We think that it will be coming from. Okay, it was not a question. Just reading that. Yeah, simulation never captures unknown unknowns. Yes, but probably it will be already visible within the scenario, and the scenario will tell us what needs to be tested and what is required from the test case itself tells us what is required to be tested, and then we can it might be required to be tested on the proving ground by looking into the test case.
Then you have another question on Open Scenario, asking if it's going to be an open access tool.
Okay, so Open Scenario is a format. It's a way to describe scenarios. It's not a tool. It can be used in different tools. There are currently some tools already on the market which can test with Open Scenario, which can use Open Scenario, but Open Scenario itself is not a tool, but it's a format to describe scenarios. And it's open, so the standard is open.
Okay, so far that's all we have as questions. If there is anything else, don't hesitate. Oh, we have something else. Is it possible to export OpenStreetMaps to Open Scenario? From Eric Waters.
Okay. OpenStreetMap would be more. It would be more convenient to export OpenStreetMap to OpenDrive. So OpenDrive holds the road information and so on. There are some exporters to export OpenStreetMap to OpenDrive, but there are not all information usually in OpenStreetMap available, which are needed for OpenDrive. So it's not that easy to just convert OpenStreetMap to OpenDrive because there's some information missing, and we need to add this information to have a good OpenDrive file. Yeah. Any other questions?
Yes. I think there's another comment from Eric Waters before we change to another questions. Where can I find more info about which info is missing? I'm not sure I understand.
Yeah, there's, yeah.
No, carry on. Okay.
There is a lot of information of OpenStreetMap, OpenDrive to be found online. And if you want to have a more detailed view, always join the other consortium. But yeah, the information can be found online. For OpenStreetMap, I'm not so sure. I think it's also online available, and it's open. But for OpenStreetMap, I'm not that aware. I'm going to find in specific documentation.
And then we have a question from Carlos Holguin asking, how can you ensure a scenario validation guarantees safety in a specific location?
Could you repeat that question, please?
How can you ensure that scenario validation guarantees the safety? I guess in a specific location or test instance.
Okay, so the basic idea or requirement is that the scenario database holds a good representation of the reality. So it needs to be somehow verified that it's that it has a certain amount of scenarios in there, and it's near to a completeness. That's a very that's some topic which is still under research to have this completeness. But if we have a good representation of reality in the scenario database and we test against all these scenarios, then we should have tested all scenarios which can occur in the real world, and we can always put a number on the driving function how safe it is. Of course, we cannot say it's 100% safe, because yeah, that's not possible, but we can always put a number then on it and say at least how safe it is, and especially how safe it is compared to the human capabilities.
And then we have a question from Jerry Jacobson asking, how would you reason when choosing between different X-in-the-loop environments? So when to choose a vehicle-in-the-loop setup or hardware-in-the-loop setup?
Yeah, we try to, same as the allocation between simulation and proving ground, we try to keep it as efficient as possible. So usually hardware in the loop test will be more efficient than a vehicle in the loop test, especially if we need to use the vehicle on the proving ground and just simulate some targets. Then we are restricted first to the proving ground. We need this vehicle and we need to really drive this test. So then we would choose try to allocate it to hardware in the loop. So most of the components should be virtual as long as it's possible, as long as the test allows it, and the test results can be verified, and we just allocate the components to real components, to real test instances if it's required.
Okay, we have a question from Francesco Valentini asking if we're going to address a unified approach or methodology to be used for the testing with simulation, X-in-the-loop, and proving ground. I guess that's the goal of the project.
Yes, of course, that's the goal of the project. Yeah, and we want to demonstrate the whole methodology we are developing in Head Start. We have another work package dealing with that. So currently we defined the methodology. The next step is then to define the process, which will be in the next presentation. And then we also want to demonstrate it on after that. So on specific use cases to show how the methodology and process are working.
We have another question bouncing on the question on safety and asking from Carlos Holguin, which indicators do you use to define safer? I guess talking about the scenarios.
Yeah, okay. That's a very good question. If we really look into safety assurance, we need to take a look into especially crashes. Then we can compare it to the human capabilities, but it entirely depends on the pass-fail criteria. So we need to take a more deeper look into pass-fail criteria, and we might also take into account the severity of the specific crash and compare that. Okay, I think we should go now to the next presentation and then have another question and answer around in the after that. After the process definition, of course, you can also once again ask maybe some questions to the overall methodology. Okay, so I would now give over to Bernhard from Virtual Vehicle with the process of Head Start.
Okay, thank you very much. I will continue the webinar with a presentation about the Head Start process. So Nicolas already talked about the methodology, which is the basis of this process. So therefore, you will see some similarities to the methodology. The approach of our work was that the methodology was transformed into a process. So the basic parts of the methodology were taken over, sorry, and then further steps were worked out more and more in detail. So wherever it was necessary, also some parts were added. This was done in several iterations until the process showed a level of detail that was satisfying for the project partners. So at the moment, we are working on transforming this more detailed process into a procedure. We are following the definition described on the slide, that a process is about what to do and the procedure is about how to do it. But this is still work in progress at the moment. On this slide, you can see on the right side a high-level representation of the process. I will use this representation to give you an overview of the work, because the detailed process would be too big for a slide, and it would be too confusing if I would split it up into several smaller parts. So therefore, the high-level representation of the process. On the left side, you can see the nine phases of the process. You will see the similarities to the methodology here. The phases are scenario selection, scenario allocation, testing method coordination, and then the 4 testing methods: field testing, virtual testing, extended loop testing, proving ground testing, then also cybersecurity and evaluation. The assignment to these phases was made in such a way that each phase has a main person responsible for the execution of this part, and as soon as this person changes, a new phase begins. So the first phase is scenario selection. The necessary input for this phase is a concrete description of the capabilities of the driving function, which should be safety validated with the process. This includes the dynamic driving task, the DDT, which defines all the real-time operational and tactical functions needed to operate the vehicle equipped to the driving function. Another necessary input is the operational design domain, the ODD. The ODD defines under which circumstances the automated vehicle can execute the DDT, and at the same time defines the limit of operation for the function. And in this first process step, a query has to be created using the information from the DDT, from the ODD, and from the use case. And since there is no standardized format for describing the ODD yet, formalizing a concrete query for a database depends on the actual database. So using a keyword-based query is one of the possibilities therefore. The query is passed to the scenario database. The database selects the relevant data and converts it to the requested output format. Currently, as also Nicolas said, OpenScenario is the most promising data format, and it is expected that scenario databases will use this or some further developments of the specification. So the selected scenarios are then made available in a data bundle, including an OpenScenario file, OpenDrive file, and ideally also a file with the parameter distributions. Next, it has to be checked whether the scenarios that we received from the database already cover a significantly large part of the ODD and test all the relevant functionalities to ensure a sufficient safety evaluation of the driving function. If this is not the case, we have to add more scenarios. Therefore, it is important to have one or more experts who can plan and create such scenarios in the same format as the already existing ones. To have enough coverage to form safety case for the driving function, it is important to evaluate one scenario description with as many different parameter combinations as feasible. But that, of course, means that the effort of the tests increase, and therefore it is necessary to evaluate the importance of the individual parameters. So the important factor for this are the key performance indicators seen here in this step. All parameters that refer to the key performance indicators are prioritized. So this results in a ranking of the parameters, and it can be estimated which parameters should be varied more and which parameters less. And to be able to vary and combine the relevant parameters in a meaningful way, the corresponding parameter distribution is required. Otherwise, it's not possible to make a distinction between scenarios which are unlikely, but maybe interesting because they can uncover some unknown situations, and typical traffic scenarios which occur relatively often. So ideally, this parameter distribution, as I said before, is provided by the database. If this is not the case, this distribution must be defined manually by some experts. And finally, in this first phase, a few feasibility checks needs to be executed, like is a certain parameter combination physically possible, or is this parameter combination even interesting? So after those feasibility checks, the number of parameter combinations should have been reduced to only concrete scenario descriptions which are physically possible, interesting, and of course also permitted by traffic regulations. So the next phase is scenario allocation. Here the scenarios will be allocated to the testing methods. Before this can be done, Nicolas already mentioned it, the capabilities of the testing methods, virtual testing, extended loop testing, and proving ground testing have to be defined. Regarding the sensor or sensor models, the environment or environment models, and the real vehicle or vehicle dynamic models. So this information can then be combined to a recorded map of capabilities. And after this process step, it is known what the testing methods are capable of. And then the allocation phase has two different branches. So the first one on the left side allocates the scenarios to 1, 2, or all 3 of the testing methods. For this purpose, the requirements of the scenarios are compared with the capabilities of the testing methods. So in this way, it can be determined which testing methods are suitable for each of the scenarios. The final decision if all possible testing methods will be used or just some of them will then be made by the target group. So scenarios can be allocated to only one testing method, but also if possible or if wanted to 2 or all 3 of the testing methods. There's also an optional second branch of the interface, which is used if there are other requirements that have to be tested that are not covered by scenarios from the database. So in the HeadStart project, this refers to the key enabling technologies, communication, positioning, and cybersecurity, which have a special position in the project. However, the process is designed in such a way that this part is not limited to that, but it can also be applied to other requirements, because we try to keep it more general, so that the process is not limited to the needs of the project. It can also be used furthermore. If such a requirement exists, it is checked whether it requires a special testing method, or if not, which testing method can it be allocated to. Then it is also checked if this requirement can be integrated into the data format of the scenarios from the database? If yes, then this will be done. Otherwise, a scenario has to be created for this requirement. In this case, it's also possible to create scenarios under quotation marks, for field testing. So at the end of this phase, all scenarios are allocated to one or more testing methods. The next phase is testing method coordination, and this basically consists only of one task. So the target group has to decide the order in which the testing methods should be executed. So it is possible to choose a specific testing method first, or you can also decide to run all the tests in parallel. For example, it is possible to start with virtual testing only because it's less expensive and more scenarios can be run. And then after successful execution, maybe go to the proving ground. So this provides the necessary flexibility in the execution of the tests. So then continue with the first of the testing methods, field testing. So field testing has a special position among the testing methods because it's not possible to reproduce scenarios exactly in the field tests. However, certain requirements like positioning or communications can be tested. And for this purpose, first a route has to be defined, or a route has to be found that fulfills all the criteria of the scenario, and of course on which it is authorized to carry out such tests. Then the tests can be prepared. This preparation phase includes the test procedure, as well as the preparation of the equipment like the vehicle, the sensors, data logger, and so on. But of course also make sure that the availability of drivers are ensured. Also things like traffic conditions, like weather, like road conditions could be an important factor to carry out these tests. Once all preparations are made, the tests can be performed, the log data is stored, and can then be used for evaluation of the tests. The next testing method that we talk about is virtual testing. Here also strategy has to be defined, how the tests are performed and what is needed for it. So this includes, first of all, an environment simulation tool that can process the scenario data format. It has also to be distinguished whether the simulation models that will be used for vehicle and for sensors are already validated or not. If they are not validated, then it's possible to carry out the proving ground tests for the same scenario first, and then use the data from these tests to validate the simulation models for virtual testing. And once all components have been validated and all the models have been coupled, the simulation can be carried out. And of course, the advantage of virtual testing is that a large number of scenarios can be run and that it can also cover potentially critical parameter ranges. What also should be considered is data management here, because the number of tests could be quite high, and the higher the number, the critical the data management could be. Next is X-in-the-loop testing. It's in some ways very similar to that of virtual testing. So we have simulation models that have to be available and validated, but depending on excuse me. Depending on what is in the loop, the corresponding infrastructure has to be prepared as well. and it has to be ensured that the integration of the infrastructure into the simulation environment works properly. As in the virtual testing, simulation models can be validated by test data from the proving ground. And after all preparations are done, the tests can be conducted, test data is stored, and for further processing. So the last testing method is proving ground testing. In the contrast to field testing, there is no need to select a track because the proving ground itself was already defined in the scenario allocation part. And based on the capabilities of this proving ground, the scenarios are assigned to the testing method. So we can be sure that every scenario that was allocated to the testing method can be executed on this proving ground. Then also a test strategy has to be defined. It has to be ensured that the infrastructure of the proving ground is prepared for the tests, as well as the equipment. In addition to the equipment of the field tests, vehicle, sensors, and so on, it's also necessary to have all the targets ready that will be that will represent other cars or other road users. And after the tests, the test data have to be saved for further processing. And as mentioned before, the test data can also be used to validate simulation models. Then the next phase is cybersecurity. So cybersecurity is a key enabling technology in the HeadStart project, but it's of course also a key area outside of the project. Therefore, it's important that it has a position within the process. But in contrast to the other key enabling technologies, it was not possible to integrate the cybersecurity completely into the existing structure of the process. So therefore, there's a separate cybersecurity part on the left side of the process, which is connected to the main process. But the cybersecurity part is kept such that the execution of the process steps is optional. I don't want to go into much details for the cybersecurity branch of the process because there is a separate webinar on Friday where a more detailed presentation of the cybersecurity topic will take place. I just want to mention that the approach is based on the common criteria, which was adapted into the automotive domain. So what I have to mention is while some parts of the cybersecurity could not be integrated into the process, there could be some cybersecurity related requirements that can be tested by one or more of the testing methods. Therefore, the branch on the left side is connected to the main process and to the goes right to the scenario allocation part. And these requirements can then be allocated to the scenarios and to the testing methods, like the other requirements. And then the tests can be executed, and after the tests are executed, the test data that is related to cybersecurity is then returned to the cybersecurity part of the process. And then there's the evaluation part. This phase consists of two parts. So at the beginning of the process, the key performance indicators have to be defined. The target group has a significant influence on the choice of the KPIs. And then it has to be defined how these KPIs are verified. So these two process steps influence many of the other process steps, so it's important to have it right at the beginning. They influence the scenario selection, the scenario allocation, but also the test itself. The second part of the phase begins after the tests have been performed. So the relevant test data is extracted and compared with the KPI requirements or with the criteria that have been defined at the beginning of the process. And these results are then evaluated and combined with the data from the other testing methods to create some kind of report. And this will be then the output of the process. And this is also the end of my presentation. So I hope I could give you a good overview of the head start process. And if you have some question, then please let me know.
We don't have new questions. However, there's one question we couldn't answer earlier due to time. So maybe Nicolas could answer it. Was a question from Rodak Alexandra asking, do you consider takeover control and request to intervene in scenario selection? I don't know if Nicolas is still available.
Yeah. Yes. So yes, we take that into account, especially also the minimum risk maneuver. We need to take that into account in the scenario selection, which is part of the driving function and therefore also input to the scenario selection.
We have another question from Tom Johnson saying, thanks, Bernard. I'm curious how we can be confident of sufficient test coverage using either or multiple of the defined testing routes.
Please, could you repeat the second part?
Sorry. How can we be confident of sufficient test coverage using either of the defined testing routes?
The defined testing, you mean the which of the testing methods?
Yeah.
Okay. Yeah, what we do in the scenario allocation part is we try to find out which scenarios can be or are possible to test at which testing method. So this is the, let's say, what's possible, but what should be done to cover everything what covers to make it sufficient testing is then be decided by the target group. So the allocation part says this is possible to test, but what's tested then has to be decided by the target group, and they have to make sure that they provides the sufficient coverage of the tests.
Then we have another question asking if we can give more details about the allocation of scenario to test methods. Do you suggest a complex approach, or do you use some kind of filtering regarding to need of sensor models?
For example, for the proving ground testing, we have to we call it extract logical elements from the scenario. So we try to filter out what elements like traffic elements. Do we need bridges for the scenario? Do we need intersections? Or which kind of vehicles do we need? So we try to filter this out. And with this information, we can, for example, see what's possible on this proving ground. For the other parts, we look more on the parameter ranges and with virtual testing, quite a lot is possible, but we have to look at how detailed our models are, how detailed, for example, the sensor models are, and we have to find out if that what's needed from the scenarios can be achieved by the testing method.
Then we have another question asking, generally speaking, what kind of KPI should be considered for the scenario selection?
That is something we decided that at this moment in the project that the decision which KPIs are important should be decided by the target group, because I think depending on which target group is looking into this process, the KPI could vary a little bit, and therefore, or maybe not only a little bit, and therefore it's up to the target group to define what are the indicators that they want to focus on.
Yeah, I would like to add that we are taking a look into different databases, and they are offering different parameters and KPIs to be available. So that also depends on the database we are using in the end.
Then we have a question asking, how do you propose to handle the environmental conditions such as rain, fog, low sun, etc.?
Yeah, how to handle it in our approaches, it's like that first we have to identify which are the conditions that we need for the scenarios. For some scenarios, maybe it's not that important how the weather conditions are, but for some other scenarios it's important, and we have to make sure that this is a part of the planning process, of the strategy process, and that I mean, it's hard to, especially in weather and road condition more, but with weather conditions it's quite hard to plan it much in foresight. But we have to make sure that before we start the test, that all these conditions are in a way that it's correct for the scenario for what we need. Because if we conduct the tests and then we see that afterwards that the weather conditions were required, some other weather conditions were required, then it's too late. I mean, that has to be prepared in the planning phase, and we have at the moment not more details that I can tell you, because as I said in the beginning, this is now the process that I showed you. So we define it so that the process is what should be done, but how exactly it will be done, this will be carried out in the procedure, and this is still work to do.
Okay, and then we have a question about the method for evaluating scenarios. Which factors are you going to assess?
Which factors?
Yeah, I guess it's in the testing process, but like which factors? I don't know. Maybe Rodak, Alexandra, you could precise your question. The question is, what will be the methods of evaluation scenarios? Which factors are you going to assess?
So how the evaluation part exactly will look like is also work under progress. So at the moment, this is not something that I can give you a specific answer to. I'm sorry.
So far, that's all we have as questions. Is there anything else?
Okay, then I would like to add that, as already said, it is important for us that you send us some feedback on the overall methodology, that we get some ideas of different stakeholders, what is important for you within the methodology, what maybe needs to be refined. Same, I think, for the process. So we need your feedback. So if you have some feedback afterwards, just send it to us, You find all the information on the Head Start website. Yeah, tomorrow and for the rest of the week, there are also webinars on the use cases, on the key enabling technologies, and so on. All this information can also be found on the website, and you're highly welcome to join these meetings as well. Okay, if there are no more questions, I think we can close the meeting. So thank you for joining, and have a nice start in the week, and hopefully see you in one of the next webinars.
Also, thank you from my side.